All right. Hello. Let me just see if everything's running okay. All right, I'm just gonna wait a few minutes, maybe just 2 minutes before we get started. Okay, I'm just checking on my phone if the live stream is working fine. Looks good. Okay, maybe just another minute. All right, that's a minute. I'll just get started. Yes, and we are live. Welcome, Peaceful Spirit, Mi Myo Hong, Stan, Confidence. I see you in the chat. While you're waiting or for us to get started, you can message where you're tuning in from. It's always cool to see where you guys are listening from. All right, we have 11 people, so we'll just get started right away. Just before we begin, I want to quickly shout out that we have our annual flagship conference, Sui Basecamp, where last year it happened in Paris, and this year it's going to happen in Dubai during Dubai Token 2049, blockchain week, or Token 2049, yes. Our Sui Basecamp will take place on May 1st and May 2nd in Dubai's Intercontinental Festival City. For more information, you can head on over to this website and sign up there. And next, we have Sui Overflow 2025. This is our annual or biggest flagship hackathon that takes place online. It started in February, but it goes all the way until May 11th. So if it's not too late yet, you can build your project now and submit it by May 11th, and you're still good to go. So you can head on over to overflow.sui.io and look over at the tracks available, prizes available, and if it's for you, then we'd more than welcome you to submit a project there. And if you have any questions, you can hit me up on Twitter. It's the Harrison Kim. All right. So Sui, we started mainnet on May 2023. So it's a little less than 2 years. So our 2-year anniversary is coming up in less than a month. Sui was the global coordination layer that went live May 2023. And then Liston Lab contributors, our cryptographers and engineers, they worked hard in creating ZK logins, so logging in with your, for example, Google email addresses. Then they built SuiNS, so human readable names instead of complicated text and number addresses. Then there was DeepBook, a global liquidity layer, Walrus, global decentralized storage layer with secure programmable data persistence. And now we are here today to listen to Joy, who's a cryptography and software engineer from Liston Labs, to go over this hot, like straight out of this, engineer and cryptographer's blacksmith den. She'll be going over some extra functionalities that will supercharge this combination of technology and Walrus. So without further ado, I'm gonna invite Joy. Switch over.
Hello, can you hear me?
Yes, I'm gonna end my sharing and you can share your screen. And
Great.
Yes, welcome, Joy.
Hi everyone, this is Joy. I'm a cryptography engineer at Liston Labs, and I'm here to Really excited to talk to all of you to introduce some of the crypto primitives and features that we launched recently. And in particular, I wanted to cover from a developer perspective how to use these features, and hopefully they're useful for the Overflow hackathon that Harrison showed. Please join. It's not too late. We actually just launched the feature, so it's like a great opportunity, and you guys are one of the first to hear about all the details.
Yeah, listen to her. All right, while she's sharing her screen, just shout out to the people who commented earlier. We got Peaceful Spirit coming from Tulsa, Oklahoma, United States. Confidence from Nigeria. Neelin from Bangkok, and Bugs from Philippines. So welcome. We have the slides ready, and I'm going to go off stage and mic over to Joy.
Cool. All right, let's get started. So a quick agenda for today. We're going to cover 3 topics. The first one about Passkey is a new wallet feature. It's a great new way that you can create wallets and sign transactions using the super secure technology called Passkey. And secondly, I will cover Seal. I'm sure a lot of you have heard of it recently. It is an access control layer built on Sui. In particular, it works with as an encryption layer for content over auras. And thirdly, I'm going to talk about Nautilus. It's a new verifiable off-chain compute framework for Sui that we recently launched yesterday, actually on testnet. So this is the first time I'm kind of talking about it. And of course, there are many other cryptography features that are eligible for the hackathon, but I wouldn't spend a lot of time covering things like randomness or ZK logging, etc. Cool, let's get started. So Passkey is a new this new authentication scheme that we introduced to Sui, currently live on testnet. For those of you who haven't heard of Passkey before, it is a standard introduced across many tech companies to standardize a way to create private keys on a device. The goal is to replace password for a lot of the websites. So there are a couple great features that about Passkey that makes it a great like scheme for creating wallets. The first one is because Passkey once created, they cannot be extracted from the device, so you can't export it anywhere. So in some way, it is extra secure, and you can think of it as like a hardware wallet in some way. With the benefits that you can actually create the private key across any devices. When I say devices, I mean practically anything like your phone, your Chrome profile, YubiKey, and Ledger, or other hardware devices that supports the passkey interface standard. So a great way on the right, I took a screenshot. This is how when you're creating a passkey, it will tell you what's origin, like what's the website asking you to create a passkey from, and it will you can decide yourself where you want to save the passkey. If you scan this QR code, it will be created on your phone. If you decide to just sign in with your Chrome profile, you can also do that. But it won't be it will only be synced over the cloud platform that you specify. So it is a great way to have a portable wallet because you can use your device across platform or within the platform. And another very similar property that Passkey has is that it's domain separated per origin. What that means is like every website will create a unique passkey for you. So you will end up having a different wallet, and only that website can request a signature from the passkey that is created just for the website. So it is domain separated. So it's somewhat safer in the sense that if one website is compromised, it doesn't affect your wallets created against other website. An advantage that it has compared to ZK login is that it's not bound to the identity provider. For those of you who remember how ZK login works, you actually need a Google login credential or Twitch or whatever social credential that you have. However, if these identity providers goes down or have any risk of deplatforming your credential, the wallet is considered lost. But that's kind of the benefit of passkey is that the private key itself is only created on your device, and no one else can delete it unless you do. And it also doesn't tie it into any additional factor that will control your wallet. So in that sense, it is fully custodial, self-custodial, that only you can have access to it. I added the link at the bottom. We included passkey as part of the official Sui SDK in TypeScript, and we also built an example demo showing you how to integrate passkey into your wallet or other front end. So some of the ideas for the hackathon is that you can create a wallet, invisible wallet for your front end app. Or you can also, if you already have a wallet product, you can easily add passkey as an additional signing mechanism in addition to the regular private key or ZK login that you already supports. Cool. So this is a rather quick overview of passkey. It's rather straightforward, and if you know how to use the Sui SDK currently, I'm sure you'll figure out how to use it. We make the interface very flexible and adaptable to add to any front end product. And secondly, I want to spend a lot more time to talk about Seal. As some of you already heard, Seal is a decentralized secret management protocol that leverages Sui for access control. So there are a lot going on here. I will unpack them one at a time. So what you can think of Seal is that there is a decentralized way of storing secrets, and the way that you access the secret is defined by the creator of the secret. And the way the access control is defined, we actually use Move as a programming language that Sui already supports to define such access control policies. And in some way, it's all so a little bit about like what Seal is trying to solve. The problem that that got us start thinking about this is our problems around data securities in general in the blockchain space. As you guys probably know, there isn't such access control standard in Web3 that allows people to access encrypted content and decrypt it. Even if it implements something, it is very bespoke to the product, which sometimes requires someone to register a public key, and then the other side can encrypt to that public key, and the other person can decrypt it. And there isn't any standard interface for such things. And for those of you who use the Walrus and other decentralized storage protocols, there also isn't a built-in encryption mechanism. So anything stored on these storage protocols, they're usually public by default, and you will have to handle encryption yourself. So Seal is here to address these difficulties and hopefully create a standard interface for people to access encryption and decryption keys with access control policy that they can define. And next, I'll talk about a little bit more in the technical details of how Seal work. On a very high level, you can think of Seal as has two components. The first part is the on-chain part, where the creator gets to define the access policy. And on the off-chain part, there are CO servers running off-chain, and you can think of it as many different servers, and you can actually define the threshold of how many servers you want to use the secret for. So let's first start with the encryption flow. So imagine you're the creator. As some of you might be familiar with the public key cryptography, the creator will use the public key to do encryption. So what the creator does, the first step is to look on chain for the registered key servers. These key servers refers to the off-chain key servers on the left here, and all of them register their public key and their URLs on chain. And once the creator decided what CO servers that they decide to use and a threshold that they want to define, they can then store the encrypted blob using that public key. They can encrypt that with the public key. And the creator now can either go to Walrus or other storage platform to store the encrypted blob. Note that CO has nothing to do, it's relatively independent to Walrus. It's two different protocols. So you can actually choose not to store anything on Walrus, but Walrus is like agnostic to what the blob look like. So as a second step, think of yourself as a user who wants to have access to this encrypted content. The interaction is rather simple in the sense that, as you guys are familiar, when you access a dApp website front end, you first connect your wallet. And then the wallet will essentially ask you to sign approval to have access to so that the front end will have access to certain packages. So on the right, this is an example message that you're signing with your wallet. So you can see here, this front end is asking you for approval to access certain keys for a certain package. And we can ignore the session key part detail, but you can think of this as a way that you're giving a session key permission to access the private, the CO private key for a certain package. So once you sign this message, the front end will contact the CO servers one at a time. And what the CO server does is to first look up the access policy defined on chain. So on the right here, you can see an example of what an access policy look like. It started with a function signature called CO approve. And it does this one very simple thing is to check whether you are part of an allow list or not. If you do have, you are part of the allow list, you have access. And if you don't, it will throw a no access error. So note that the CO server here is not running, it's not asking the user to execute any transactions. All it does is to dry run the transaction that is called a CO proof to see whether you have access or not. So it is a clever way of running running a view only transaction on chain by seeing if you have permission to something. And once the CO server checks your access and it does think that you have access to, you are part of this allow list, it will return a key share to the front end. And we use this crypto primitive called identity-based encryption. On a high level, you can think that the CO server knows how to return you a private key indexed by the package ID name. So now dApp gets a share of the private key because remember earlier, the creator chose a threshold of how many key servers that they want to encrypt with. So now the front end will go to different CO servers to fetch key shares until that it receives enough key shares to recover the full key that passes the threshold. So once the dApp has the full key as step 8, it will now be able to decrypt the blob with the full key. So this is how the front end will receive the full key and decrypt the file. So I'm going to show a short video of a demo that some of you might have tried it yourself before. But for the sake of time, I made a recording ahead of time to show you this exact flow of how this allow list example works. So you can also go to this website called coexample.vercel.app. So let's first look at this allow list example. So now I have an admin view, and I will create an allow list by giving it a name. This has nothing to do with seal yet. It will just be a standard Sui object. And now I'm going to switch to, I'm going to copy an address and add it to this allow list. And because I'm an admin, I have the admin cap to do such thing. And now you can see that this address is part of this allow list. And now as admin, I will upload a file to Walrus, encrypting with the public key fetched from the seal onchain registration. So the very first step is that the front end will use the public key and then encrypt the files and upload it to Walrus. And once the blobs are created, I will save the blob ID to this allow list. So now blob is attached. I can now share a link to, and then now you can see the blob is attached as a dynamic field, which contains the Walrus blob ID. So now if I share this link to other people, and for this example, I will switch to this wallet address that is part of the allow list. And because I have access to, because I am part of this allow list, I approve this access and key personal message. And then now the front end will now fetch the encrypted file from Walrus and then fetch the decryption keys from seal, achieving the threshold, which is 2 here, and then it will decrypt this file that it found on Walrus. However, if I switch to a different wallet address that is not part of the allow list, and then now I click download and decrypt all files and approve that personal message, and now it contacts the seal server, and then the seal server will respond that I don't have access to decryption key. Why? Because it dry runs the transaction and it checks if I'm part of allow list or not. So this is a whole flow of how seal works, front end to end, and you can find this example app as part of the seal repo on GitHub that is public. And to give people an idea of what they can build with seal, imagine that you can actually define all kinds of access policies. For example, you want someone to purchase a certain subscription to have access to the file, and you have to pay a monthly fee to continue to have access. Or you can also build a token-gated experience to Walrus files. For example, you need to hold a certain meme coin, or you need to pass a certain threshold of a token balance to view some content. And some of the other ones include secure messaging. Imagine you create a group chat, and then only the people in the group chat can have access to the decryption key from seal. Therefore, they can view the files that you uploaded. In addition, because the access policy is defined in Move, there are all sorts of Move features that you can leverage in your access policy. For example, you can use the clock object to define certain encrypted material can only be decrypted after a certain time. For example, if you have a vote, you want people to vote, and the vote itself are encrypted, and only after a certain amount of time, everyone can see everyone's vote. And not to mention, you can also build games that with states that you want to be encrypted. For example, card games or anything that with a state, and only the people who has the right to decrypt can decrypt the card game state itself. So how to use seal? It's actually fairly straightforward. The first step is that you need to define access policy in the move package. And secondly, you will integrate with the seal SDK frontend. And on a high level, there are two big features. One is to encrypt and one is to decrypt. And to decrypt, the first step is to fetch a key from seal servers. And the best place to start is by looking at the seal repo. And in the README, we have a very detailed introduction about Seal's feature. And if you care about how to use Seal SDK, go to the Using Seal section. And it roughly describes what I just talked about. The very first step is that you define the access policies in Move by using Seal approve. It can have any inputs as much as you want, with some limitations. But in general, it just has to start with Seal approve so that the Seal server later can then find such function to check if you have certain approval policy. As I mentioned earlier, the allow list example is one way of defining your access policy. And of course, you can also define with NFT gated experience or anything that involves randomness object or clock object or anything you want that is available in Move. And at the encryption step, the encryption step is rather simple. All you need to do is to define a Sui client and a list of Seal server object. And currently in testnet, Miston runs 2 key servers in testnet. So you can use this function called getAllowListed key servers, which will fetch the 2 Seal server in testnet that Miston runs. And for now, you can define the threshold as 2 to use that. And the encryption step is just using this Seal client that you defined earlier here to invoke the encrypt function. And the encrypt function takes a few fields. The first one is a threshold. For now, you can define for 2 for simplicity. And then you need to define the package ID that you actually define the access policy in. And the data here is the raw data of the raw bytes of a certain file. So for example, in my previous example, this will be the byte stream of the Seal picture that you've seen in the UI. And some of the technical details, the encrypt function will give you the encrypted object and a symmetric key for encryption, and then it can be used. It is the file that is used to encrypt the file. And the second step is to finish your decryption logic. The decryption logic has two components. The first component is to define what is a session key. And the session key is an object that contains the the Sui address that is owned by the user, and it also provides these functions such as get personal message that will assembles this personal message that you need to sign. And as a front end, you may use the dApp kit to define the wallet pop-up window for a user to sign the message. And once you have that signature, you can use the set personal signature to set such signature. And then this session key will later be used as an input for the decryption function over here. And the decryption function needs to be provided with 3 inputs. The first one, obviously, is the encrypted bytes that you want the CO client to decrypt for. And secondly is a session key, which is not expired and also has a personal message signature set. And thirdly, this decrypt function needs a transaction bytes. And as we mentioned earlier, we need a way for the CO server to find the CO approve function. So in our very first example about allow list, this CO approve function essentially takes in the sender's address and the allow list object ID to provide inputs for this function. Just like how you build a regular Sui transaction, you can use the Sui SDK to build such transaction as well, and then provide it as part of the input for the CO client.decrypt. There are ways to optimize the CO client as well. I won't spend too much time talking about it, but basically, before you call the decrypt function, we also expose a fetch key function that actually allows you to fetch multiple CO keys for transaction bytes that contains more than one programmable transaction block of CO approve. So for example, if you need to fetch if you are sure that you as a user, you have access to 2 different allow lists, you can compose them into one PTB and pass them together as a fetch key. And once you write such function, when you later call CO client.decrypt, it actually will use the cached key that is available in the CO client to decrypt. So it's a optimization on the decryption flow. This is basically how you would use the CO SDK. I know some of you may be interested in running a CO key server. We also open source the code on how to run a CO server using the CO CLI and the server code. And I'll leave this to you guys to read the instructions. Cool. So I know that I covered a lot on CO. I think we'll have time for questions later on. And for now, I will continue to talk about Nautilus. This is a very new feature that we just announced yesterday about Nautilus. It is a new framework that we propose for developers to build dApps with off-chain components. So what that means is like we're actually using Nautilus as a way to bring off-chain compute on-chain. As you guys, there are some obvious problems with on-chain, fully on-chain applications these days. And first of all is if you wanted to use any off-chain data on-chain, you're sort of trusting the data provider to post the correct data. So for example, if I am an exchange and I have Oracle data for Bitcoin price, for example, and I post that data on Sui blockchain that supports a lot of decentralized exchanges, you're sort of trusting me to not post the wrong price. So, for example, I could post a price from Coinbase.com, but on the other hand, I can also post the price from a fake Coinbase.com that can be completely wrong, but you sort of have to rely me on that trust. And a second problem with on-chain compute is that you can't really work with a private state. So some of the example includes, uh, for example, if you want to run an AI agent that interacts with Twitter's API, you can't really store the API key of Twitter on chain. So you sort of have to run some compute off chain to support that. So the question comes here is that how can we bring off-chain computation on-chain in a verifiable fashion? What I mean by verifiable is that as someone who sees off-chain data on-chain, how can I trust that it is indeed the data I see, and I don't have to rely on the off-chain operator to tell me that is true? So at the very beginning, I want to take a small detour to talk about trusted execution environment and how it actually solves the problem we mentioned here about verifiability. So TEE is an acronym for Trusted Execution Environment, and some of you might have heard about it. It is a solution that is deriving the trust from some hardware or cloud providers to run the certain software that they claim to run. And the TE comes with two flavors of features, very powerful features. The first one is verifiable. This sort of solves the problem mentioned earlier around verifiability. So how do we have verifiability of the trusted execution environment? The way how it works is that for an TEE, the hardware provider or the cloud provider can provide a remote attestation document, and it is a document that contains the unique measurements of the software running in the enclave. And what that means is like if I write a software that pulls Bitcoin price from, let's say, Coinbase.com, you as a user, you can look at my code and then build to a particular binary, and it will match exactly with the binary that the remote attestation had signed over. So in some way, you can trust the response from the TE because you can independently verify such remote attestation. It's not only on the data that you ask the enclave to process, but it also is over the software hash or binary that is running inside. And secondly, TE comes with another feature is about confidentiality. Because the TE runs a particular isolated compute environment, and and that no one else has access to, you can encrypt data to this enclave, or we call it TE, and only the enclave itself can decrypt such data. So imagine that you can even send sensitive data to the enclave, and you can have guarantee that only the enclave can decrypt such content. So Nautilus is a framework that we provide that has two parts. The first part is the off-chain enclave software template, and the second part is the move verification ability to support verifying remote attestation from AWS Nitro Enclave. There are many forms of TEs out there, and we choose to support AWS Nitro Enclave because of its maturity and also because of a very important feature called reproducible build. Why is reproducibility important here? Is that we want every enclave can be built by you and someone else and everyone else around the world, and they can actually verify that the software running inside the enclave is exactly as the developer claims to. So that is a very powerful feature because as an Oracle provider, I cannot say I'm fetching price from a fake Coinbase.com. Instead, it has to be Coinbase.com. And if it changes to fake Coinbase.com at some point, the software measurement will be different and you cannot verify that on chain. So Nautilus, what it really is to bring such verifiability of an enclave in Move, so anyone can bring any off-chain data into Sui Move in a verifiable fashion. So how does Nautilus work? It comes in two steps. The first step is you as a developer, you can deploy your own enclave software and then register the software measurement on chain in an object. And secondly, as a user, how you can use the data from the enclave is that you can first interact with the enclave to process any data and get an attestation. So for example, if I wanted to know the Bitcoin price, I will first talk to the enclave that I made sure that is indeed talking to Coinbase.com, and I fetch such price, and then I can verify the attestation inside my Move contract and use the Bitcoin price that I fetched from the enclave. So let's break that down into a little more detail. So as a dApp admin, the first thing I do if I wanted to use the Nautilus feature is that I will first publish my code for verifiability. And secondly, I will register the expected measurement. We call it PCRs. We will register these measurements on chain. And because I'm the owner, I can update it if needed. And thirdly, I will deploy and run the enclave inside the AWS environment. And this AWS environment will have a server that essentially provides an endpoint to process any data. And later we'll show example of how to write such enclave using the Nautilus template that we already provided. And then because now I have a deployed enclave, I can get the attestation document by asking the enclave to return me a signed document over the PCRs, that is the software measurements, and the public key inside the enclave. And as a dApp user, the step is very simple because now you can derive the verifiabilities of the code. The first step, optionally, you can confirm that the PCRs that indeed matches the on-chain state before you interact with the enclave. And then the second step is to talk to the enclave to process certain data. For example, fetch the Bitcoin price from Coinbase. And thirdly, you will have a response from the enclave that is signed by the enclave key, which is registered directly by verifying the attestation document. And now that you have a data and an attestation that data is indeed authentic, you will then use the data in your on-chain contract. So at the very first step here, you can see in this example function called do something, the very first step is that you will verify that the signature indeed is verified over the enclave public key. And then now you have the trust of such data in a Move contract. You can then use the response. So in the early example, let's say you can use the Bitcoin price from now on. So how to use Nautilus? There are 3 steps. The very first step is that you will need to write and deploy your own Nautilus server using the template that we provided. And note that this template actually does a lot for you, including giving the enclave access to certain domains on the internet, because enclave doesn't come with internet connection for free. You will have to forward the traffic from the parent EC2 instance. And once you deploy your server, the second step is to register the measurement and the public key on-chain. And the third step, it requires you to write your own dApp application that verifies the process data and its attestation. Then you can use the data on-chain. So I'm going to show a quick demo here that we also open sourced and we can look at and in a moment we'll look at the code together. So this example called Nautilus-twitter.vercel.app, it is an example application that we built with Nautilus to fetch your tweet inside the enclave and provides attestation over your Sui address and attestation of your Twitter name. And if that attestation verifies, the on-chain contract dApp will mint an NFT for you. So as usual, you will first connect a wallet. Let's use the 4668 here. And now me as the owner of the Miston intern Twitter account, I will tweet this address in a tweet. And now I copy the URL of such tweet and paste it into this link. And what this link does, this button does, is that it talks to the Nautilus server running inside Enclave to get a signature over your Sui address and your Twitter name. And once I approve such transaction, now I got a minted identity in Sui, and you can see that this NFT contains my Twitter name and my Sui address. And as I mentioned earlier, how do we derive the verifiability of the enclave? Can I trust it? In fact, you can go to the open source repo and build the repo yourself and verifies if the hash of the build in fact matches with what you see in the enclave configuration object registered by the enclave admin. So for example, here, this is a Twitter enclave object that I registered that contains all the PCRs. You can think of them as the enclave measurement. And they're posted here. And I'm going to skip the build since this will take some time. And eventually, after the build, you can see that the PCRs built locally matches exactly like the admin says. So now if I do find the measurement here, that one start with 8912, it is actually matching exactly like what the admin registered here. So what does that mean? It means that if you go to the Nautilus repo, a Nautilus Twitter repo, and you look at the source code that actually implement the Twitter logic, and we go to this file, you can actually see the process data endpoint is implemented exactly like what I claimed. That is to fetch the Twitter API and extract the tweets, and find my Sui address in front of the hashtag Sui. And by doing this exercise yourself, you can actually trust that the enclave is running exactly the code as you see in front of you, because they built the same binary SHA measurement. And the best place to start by building your own enclave and use it is by looking at the Nautilus repo. It is provided as a template, And as usual, we provided an overview. And if you go to using Nautilus page, you can see how exactly you need to do to deploy an enclave. As a developer, the very first step is to register, have an AWS account, a developer account. I won't go over this part here during the call, but encourage you to follow through it. It will require you to have some prior knowledge around AWS, and if you don't, this is a great opportunity to learn. And we provide a very simple script that it allows you to run an enclave and expose the endpoints. And in this particular example, you will only need to you can use the template and only need to modify certain files to your own logic. So in particular, you will need to update the allowed endpoints.yaml file. This is the file that contains all the domains that you need the file to have access to. So, for example, in the Nautilus Twitter example, we see you will actually need api.twitter.com because your enclave needs access to such file. In addition, you will modify the app.rs file that is also part of the repo, the template. You can see that app.rs, it is the core Nautilus server logic, and you will need to replace it with your own relevant endpoint that does certain things. For example, this endpoint process the Twitter content. Alternatively, you can fetch the Coinbase data or do whatever you want in your process data endpoint. And finally, this is a template. It contains a lot of endpoints that you don't typically need to touch. For example, the get attestation endpoint. And now that you have an enclave running, you can now build the enclave locally to check reproducibility. And as what I shown earlier in the recorded video, you can do that yourself and ask the user to do that yourself. And then as an admin, you will register the enclave on-chain now. We also here provided a lot of script for you to follow through, and it requires you to publish your dApp in a move package and also inputs your enclave URL. The registration steps comes in three steps. The first step is that as an admin, you wanted to update the measurements of the enclave that you deployed exactly by using the PCRs built locally. And you can only do that because you are the admin, you are the owner of the examples package ID deployed above. And optionally, you can update the name, for example, the name of the enclave and a certain date. And thirdly, we wrote a register enclave script that takes in these inputs. This script assumes that your enclave exposes a get attestation endpoint, which is provided by the Nautilus template. And once it has the enclave attestation, it will register the enclave object on-chain. So here's an example of the enclave config that I showed earlier that contains PCRs. And then it also has an example of the enclave object itself. This enclave object itself just contains a public key, and which will be used later on by your dApp. And finally, now you have a dApp deployed and also registered your enclave on-chain. You can now interact with the enclave and use the dApp. So in the Nautilus example, you can find the front end that actually does certain things. And in this example, in particular, we provided a script that also does that. It will use the enclave object and the signature to update a weather on chain, and as a result, it will create an object with the data provided by the enclave. So in this example, the enclave is fetching a weather data for a certain location, and then once it's verified, it will post the data on chain. Cool. So this is like a very short coverage of how Nautilus work and how to deploy your own enclave and use it on chain. And finally, I want to end with what you can build with Nautilus. As mentioned earlier, because Nautilus can bring any kinds of off-chain compute on-chain, there are many possibilities of what you can build that are traditionally not possible to build fully on-chain. For example, you can build any kinds of oracles for prices, weathers, sports, IoTs. Alternatively, you can also build AI agents that has workflows and on-chain state. You can think you can run a Twitter bot inside an enclave and do certain things where you can use the verifiable on-chain state. And last but not least, you can also have any kind of private computation logic running inside the enclave for KYC purpose or for any auction or trading purposes where only the enclave has access to certain information. And not only that, it also provides the verifiability over that confidential data. Cool. I know I covered a lot today. I will leave some time for questions. And we also post the Discord channels for Seal and Nautilus. If you have any specific questions, they're relatively new features, so always welcome feedbacks and questions and anything you want to contribute. And for anything else relating to passkeys, randomness, etc., they're also eligible for the cryptography hackathon track. And if you have any questions there, feel free to post in a dev discussion channel, and our team will be happy to help.
Okay, thank you, Joy. I think this is time for Q&A. But first, if you guys enjoyed Joy's explanation of these wonderful features, please give us a thumbs up and like. And then in the meantime, I'll look for the questions that people have been typing into the comments. So the first question is from Mario. And this is a question for Passkey, I believe.
Yeah. So yes, so for a passkey, if you lose the device, it means that you lose the key. You can think of it as a hardware wallet. However, you can choose to store your key with a passkey device that is cloud-based, in the sense that if you lose your device, you will still have access to your iCloud, etc. But you're right that it cannot be exported and it also cannot be transferred. It stays in this secret place. It's actually stored in the enclave on your phone. So it cannot be extracted or transferred in any way.
Next up, we have a question from Mimio.
Do we need to trust the seal servers? Currently, the answer is yes, with the threshold. So as a creator, you can choose the seal servers that you decide to trust. If you ever want to run your own seal servers, it also makes sense in some scenarios. And a note that we are thinking about these more like trustless solutions, meaning that we want people to use like a committee of seal servers, for example, but more on that later.
Okay, I think that's all the questions we have from people asking in the chat. So right now, if anyone who's watching right now have any questions, please type your questions in. In the meantime, I'll just highlight some. Oh, okay. We have one here.
Cool. I need to verify some data uploaded to Wars that comes from my game frontend. This is handled by Sui Event and Cloud Function mode. Can I up? Is it the same question
Yeah,
or?
it's the same question.
Oh,
So
okay. Could I run these functions in a Docker container using Nautilus to verify? And can I upload, verify, and run some Sui function to be a single transaction? Yeah, that's a lot of details, but on a high level, that sounds plausible. So what you could, one way I can think of how it works is that you can implement your verification logic off chain in a Nautilus enclave server using our template, and then use that verification result with the testation on chain. And you can use it in a multi programmable transaction block that contains everything.
Next question is, or just a request of series of tutorials. Awesome. Sele, if you can explain or just give us more details, like what kind of tutorials, what topics, and on those topics, is it like lecture styles or like documentation of like a build or video version of a build, end-to-end build? Yeah, those kind of details would help us also determine what
I
kind of
guess
tutorial.
to answer the particular topics that I mentioned today, the best place to look for it is probably the docs now. I know I ran through it quickly, but we all provide example repositories that you can literally try it out yourself and then look at the code and learn it that way, maybe with some help in AI.
Okay, I see. Sally is saying like something like on code club that Cheyenne did in the beginning, in the early days. Yeah, sure. We'll definitely bring this feedback back to our team. Let's see. I heard that you want to support the Bitcoin network Babylon. I think because this is off topic, unless Joy, if you know the answer, but
Yeah, so slightly off topic, but I believe there is something in the work and hopefully announcing soon.
okay. In the meantime, while we wait for more questions, people have been raving about you, Joy, in the chat. So I'm just gonna highlight some of these. Thanks, Joy. Joy is an amazing tutor, honestly. Clap, clap, clap. Thanks, Joy. Cool tech. And you answered his question, his first question earlier. So cool. All right, we have a question. Could we extend the enclave logic to generate decentralized identity scores based on multi-platform data, not just Twitter?
I think, yeah, the short answer is yes. As I've shown, the app logic that running in your enclave can be anything that you like. It doesn't have to be Twitter. It doesn't have to be, social media even. But you just can implement any logic, fetching weathers, fetching prices, fetching identity data. A great way to think about this is like, you can implement a trusted oracle. If you want to do something off chain, do it, and you can then bring it on chain in a verifiable fashion.
Okay, and let's see. Any more questions, audience? While we wait, if you're bored, hit the like button.
I think I see one more above. Will Nautilus always be synchronous and must be complete running before transaction can be completed on chain? The answer is yes. So in order to use the result from Enclave, you will need to interact with the server first, the server running in the Enclave, and to get that attestation signature. And then you can bring that data on chain. So yeah, the answer is yes.
And I'm just sharing a link to the slides that Joy showed today with the resources. All the links basically that she mentioned are on this Notion doc. So you guys can head on over to this link that I just shared, go.sui.io/native-cf or crypto features, to access those links. One more question. Could you pass on the information to add an address book to the Sui wallet, please?
Cool. That's great feedback, and we'll pass on to the wallet team.
Okay. All right. All right. Last chance for questions. We are a little bit over time, but we love questions. So we'll just give you guys another minute to type in questions. Otherwise, yeah, please thank Joy for her time preparing these slides. And it's always not easy to lecture live stream. So I really appreciate Joy always for helping out. In the meantime, I'll just go back and just go over this again, what I did in the beginning, which is our Sui Basecamp that's happening in Dubai on May 1st and 2nd. Go check it out, find more information on sui.io/basecamp. You'll find a lot of people there from Sui and Miston Labs and Walrus. Sui Overflow 2025, the online hackathon, which is why we're doing this live stream as well, is we're hoping that some of you will take some of these features that you learned today and implement it in your projects. The deadline will be coming in mid-May, so you still have a couple of weeks to tinker something. And to find out more, overflow.sui.io. And yes, again, thank you, Joy, for your time. If we don't, okay, we have one question. Someone's asked, Confidence is asking for Joy's X account so that they can follow you. Can I share it?
Yeah, it's JOYQBQ.
All right, type it in. All righty. Cool. All right, I think that's the end. Before you guys leave, just hit that like button on your way out. Thank you guys so much. Thank you, Joy. And see you guys on the next workshop. Take care.
Thank you all. Bye.
Bye.